One of the key things we often have to deal with when we're working with embedded systems is that we tend to interface them with different types of sensors. Now, this particular TinyML Shield has got a set of pins. If we recall, on the left-hand side, we have general purpose input-output pins, which allow you to interface with digital and analog components. And on the right-hand side, we have pins that interface with the I2C protocol-based sensors. Now, I want to talk a little bit about this because on the TinyML Shield, we are in fact using these capabilities. So I want you to understand how we are actually interfacing them. So later on, when you expand yourself outside of the scope of what we're teaching, you will know how to integrate new sensors. For example, in the I2C, you can actually integrate the seed growth sensor like this thermocouple that we are showing here with just a simple cable. Now, there are many other types of sensors you might use to interface. In addition to this thermocouple, there's a Coulomb counter or a rotary encoder, or pick your favorite one from this website shown below. The key thing to understand is how these sensors are actually interfacing. And the key thing is that when you're interfacing these sensors, you have to interface them through some sort of communication module. For example, there's an old school parallel interface, as we used to call it, where you have the transmitter on the left-hand side and the receiver on the other side. And think of this as the transmitter being the camera, for instance, which is capturing pixel data. And it's transmitting it over to the receiver, which is the Arduino Nano 33 BLE sensor. And it's got to receive the data. In parallel interfaces, you tend to have a whole bunch of wires that are going from the transmitter to the receiver and uses a lot of space and I/O pins. The nice thing about a serial interface, like the one we're showing here, is that all of that data is communicated effectively over one line in a predetermined formatted sequence. And there are many different types of serial communication protocols out there. The three primary ones you need to know about when you're interfacing sensors is generally the UART, or Universal Asynchronous Receive Transmit Protocol. Then there's the I2C, or the Inter-Integrated Circuit Protocol, and the SPI, or that's called the Serial Peripheral Interface Bus. And these are all three serial communication protocols. In other words, you have a single line through which you're effectively communicating from the transmitter to the receiver and back. And now the readings and supplements will talk about this much more in detail. And I'm going to specifically focus on the I2C or I2C protocol, because it's one of the most common ways to interface with sensors. And in fact, it's one of the things that we are actually going to be using. So I want you to understand a little bit about what's actually going on underneath the hood. So an I2C protocol basically has two critical ways of communication channels. One is called an SDA, which is a serial data channel, which the data actually moves along. And the other is the serial clock channel, which actually controls when the data is actually coming in and out. And these two wires are already there. And so when you're integrating with sensors, you need to basically deal with these two pins. The nice thing about these pins is that you can actually connect different sensors to it. So you can take our Nano 33, for example, which will be the motherboard, as shown here, and connect it to the camera, which might be the child there. Typically, they are called master-slave circuits, but I prefer not to use that terminology. Now, let's get a bit more specific. What happens here is that the mother, like the Nano 33, is able to transmit data, and the child is able to receive the data. And on the other hand, the child may be able to transmit data over to the mother. Being a bit more specific in our case, for example, the BLE is a mother, which is sort of the brains, and the sensors like the camera module or the seed growth sensor that you might choose to interface. Basically, all these components, or the n number of different sensors that you might have, connect over the SDA and the SCL. And by connecting them and then programmatically setting up a mechanism to communicate between them, you can get the data in from the sensor and you can push data to another device. So just a very, very high level skim to us what's going on in terms of how the sensor communicates with the Nano 33 BLE sensor. There's often a start and a stop to a communication. Think of this as a handshake of saying hi and goodbye. So at the start, you have a special signal, which is called a preamble, where you can see that the SDA line goes low and the SCL clock signal stays high. When that happens, that basically indicates the device that you're about to start transmitting data. And the first thing that you do is kick off the start signal, and then you start transmitting your bits. And then the first thing that happens after that is that you actually start telling, what address you want to send to. So for example, let's say you want to pull data in from the IMU. Now the IMU may have an accelerometer and a gyroscope, and you want to know which one of those you actually want to read from. So in this particular case, you will give the address, of one of them. And then you will say whether you want to read or write. In our case, for example, we want to read the data from the sensor. So you will say, I want to read the data. And then after that, you'll get an acknowledgement saying, yes, things are ready to be read. And then the data starts coming in from the sensor. The data comes in chunks of 1 byte or 8 bits of data at a time. And every time 8 bits are passed back, you get an acknowledgement. And then this process repeats until there's a stop signal. The readings are going to go into much more detail. And I'm simply trying to pick up the key points that I want you to know. At this point, I just want you to know that we are trying to understand that there's an I2C protocol that has some way of communicating to the sensor, and where the sensor might actually have different kinds of pieces of data and that you might want to get to, like the accelerometer or the gyroscope data and so forth. So therefore, you have an address, and once you program it, you're able to read and write using the I2C. How does this pertain to where, and what we are doing in our class? Well, the OV7675 camera module that we are interfacing with uses a variant of I2C. Remember, I said a variant because the OV module has a proprietary I2C interface. But by and large, you find that if you look at the pins are basically the SDC and the SCL that we talked about earlier. And then you tend to have, some additional pins, and these pins are basically transmitting pixel data back to the Arduino Nano 33. And of course, then you have the power pins, which you actually need to provide power to the OV module. Just the way that the OV module interfaces to the I2C on the Nano 33 BLE, the IMU that is actually on board is already physically integrated to the board and also communicates to the processor using I2C. Now you are starting to understand why I'm actually emphasizing the need to understand these protocols, because all these sensors are basically communicating to the microcontroller using these serial protocols. Later on, when you are integrating things, you will need to know what type of sensor you're actually dealing with. So the kits that we have put together are basically using fundamental embedded systems principles, which have become common no matter, what device you pick and play with. And that said, in the next 2 videos, I'm going to focus very much on the software side and the software ML side, that we get into how the embedded system is actually going to run that. And so I'll see you there.